Okay, we're reviewing for the semester 1 pre-calc final. Of course, on the front page, we just have a list of all the topics that you need to know. You can do with that what you wish. You can, keep track of which ones you need to study more and whatever. But what I envision for you for this next, we basically have, we had a day yesterday of review. There's today, there's tomorrow, and then there's Monday. Okay, so Tuesday. You have today, basically 3 more days. I envision doing a few problems each day off of this packet. I'm not going to make up new ones. I'll do actual problems from this packet. And then I'm hoping that you nominate problems, because like if you know that you need help on this one, that one, and the other one, then I'll go through and do ones that you know you're kind of weak on. That way I'll be focusing on things at least some kids need help on. All right, so here we go. We are going to do a few problems from here. And just to get it started, I'm going to not do number 1, because I bet you everybody in here did number 1. But I want to call your attention to this one, 2B as in banana, because it has so many potential ways to screw up. I'm going to pause for a second. All right, so 2B, everybody take a look at this one. I know you just divide by 4. Well, do you know that you have to divide by 4 first and then take the square root? That's the key. Some people take square root right away, and that will mess you up. It's much better to take the divide by 4 on both sides first. Now that I've done that, I have x squared equals 25 over 4. How would you have known to do that? Do you remember that little saying, get the clump alone? Okay, the clump is the x squared. So you want to get that x squared alone first. Get the clump alone. Then you square root both sides, and then there's a whole bunch of places you can screw up here. Next part is the square root of x squared is not x. What is the square root of x squared? Absolute value of x. That's critical. You need to remember that. That's going to be on this test. Like it's been on several of our tests, because that would, if you forgot that, sorry, I got to get rid of that stupid thing. If you forgot that, you would forget one of your answers. Then the square root of 25 over the square root of 4 does work. You can break it up like that. Square root of 25 is 5. Square root of 4 is 2. 5 halves. And then again, if you had forgotten right there and just said x equals 5 halves, you'd think you're done. But it's actually absolute value of, and that reminds you that there's 2 answers. You can split it in 2 parts. X equals 5 halves and x equals 5 halves. And if you did it twice the exact same way, that'd be crazy. Throw a negative on that one. The point is, whatever's in here could either be could either be 5 halves or negative 5 halves. Therefore, it's plus and minus 5 halves. Okay. Any questions on that one before I move on? Yes, on that one? Did you get the same thing? Yeah. Then that's totally fine. Remember, factoring is one way to solve quadratics. The quadratic equation actually could have been used on this. And then the way I showed you was get the clump alone. All are good ways. All right. So I was also asked about number 1, and the person said, I don't think it factors. Well, let me check. It does say factor completely, so I'm going to see if I can factor this puppy. Ooh, that doesn't look like fun. So if I can factor it, that means first I'm going to check, is there anything that goes into all of them? And the answer is no, because 5 is the only thing that goes into 5, and 5 doesn't go into 14. So then I go 14x squared. Could I make it 14x and x? Yes. But is that the only way you could do it? No. Is that the only way you tried? Yeah. Okay. Do you get that? First of all, just to clarify it, then to try the rest of it, you'd have a 5 and a 1 and a plus and a minus, and you'd have to try to figure out where the 5 and the 1 move around to and see if you could make it work. That doesn't work, though. So if that doesn't work, you can try something else, like instead of 14x and x, how about 7x and 2x? Because that still makes 14x, doesn't it? Or 14x squared, right? And then I move the 5 and the 1 around until I find it. And let me check. I want a big negative number here. So I would probably strategically want to put big numbers on the outside to make them negative. And then make this positive, and I bet you anything that's it right there. All right. Now, again, under nominations, I hope you went through this thing. And honestly, kids a lot of times do this in the opposite of what they should be doing. What you'll tend to have kids do is they'll just do the ones that they understand, and they'll skip the other ones. Of course, if you already understand something, you don't even need to do it. You need to practice the ones you're not good at. So if you skipped any because you were like, ugh, I don't know how to do that one, those are the ones you need help on. We tried to make this review packet a lot like the final. We try to make it so, like when we look it over, we say, is there anything that we skipped on the review packet that they would need for the final? So if you understand everything on this review packet, you're going to be in really good shape for the final. But if there's anything you don't understand, I can bet you that there's probably a question just like that that you won't get. All right, so nominations now. Other questions on page 1 here that you need a little bit of help on. Don't be shy. I don't want you asking every single one you don't get all the time because I don't want one person to hog the whole thing. But if you haven't asked a question first yet, especially, are there any of these you'd like to see done? Page 1, or maybe page 1 was too easy. I don't know. Yes, ma'am. E as in elephant. 2E? All right. So here we go. It's an absolute value, and so right away I'm thinking I want to split this into 2 things. Okay? I want to split this into x plus 2 over 3 is greater than or equal to 3, and x plus 2 over 3, I make them exactly the same, and then I step back and say, well, that's not logical. I got to throw in a negative on one of them. If I make this negative, then I have to change this sign to the opposite sign, less than or equal to. You remember how if you multiply by a negative on both sides, it switches the sign? It's kind of like that. All right, so now, if you haven't already done E as an elephant, please do it with me here. 2E is where we are. Again, if you've already done that one, I understand. You can move on and work on other stuff. So, to solve these, I have 2 little equations to solve. I multiply both sides by 3 here, and I get x plus 2 is greater than or equal to 9. And on this one, when I multiply by 3 on both sides, I have x plus 2 is less than or equal to negative 9. And then from there, I bet you can handle it. Okay? And when you're done, you probably would again, it depends on how the question is worded. We didn't have much wording on these, but if you wanted the answer in interval notation, you might end up with something like x is greater than or equal to 7 is the same thing as it works from 7 to infinity. Know what I'm talking about? So it depends on how you'd want to, what the directions say. Otherwise, if it doesn't ask for it in interval notation, this is a correct answer on this side, and then finish the other side. X is less than or equal to negative 11. Can you be both things at the same time? No, but it's kind of like saying, here's negative 11, here's 7. You need to either be bigger than this, or you need to be less than that. Okay? Other ones you want to ask about. That was a good one. I'm sure a lot of people probably wouldn't have caught this little twist. I'll open it up to page 1 or page 2. Either one. It could be page 1. If it's page 1, that's fine. Okay, let's stick to the beginning here. Page 1 and page 2. Any other questions from page 1 and page 2? So, other nominations for questions you would like. Anything else on 1 or page 2 even? Okay, there's lots of pages, so I'm fine with moving on to page 3, which starts at Q there. Let me just remind you for a second on this. Can on Q, as in quilt, can you multiply on both sides to clear that fraction? Yes, you can. What kind can't you multiply on? Things like S and T. You could not multiply on both sides to clear those because those are less than signs, or inequalities, I guess you'd say, the general category. One's greater than, one's less than. Anyway, we just did these fairly recently, so I'm hoping these are okay for you. But again, if you need help on one, ask me. No nominations on that page? QRSTL or UVW? Okay, moving on to this page, problem 3. It's been a while since we've done these domains. I could do a 2-second reminder on those. This, and this. The kind you add, subtract, or multiply. It's always just the 2 parent domains, F and G, and you just overlap them. Like if one of them goes from 1 to infinity and one of them goes from 3 to infinity, you see where they overlap and you say, oh, so then they're from 3 to infinity is the domain. So you just do the two parent domains on this kind. This kind, you have to do 3 number lines. The third number line is that the lower function cannot equal 0. So you find the g, in this case, the function g is on the bottom. So you figure out that normally is okay to be 0, but not if it's on the bottom. And you say, okay, so in this case, it can't be 0. So you go back to here, and it would be an empty spot on 0. So you have 3 number lines for that kind. And this kind, you have 2 number lines. The domain of the new as also the domain of the composite, and I think that's even better. Domain of the composite. The composite function is the new function we created. And the domain of the inside, whichever one's on the inside. So in this case, it'd be the g of x. In this case, it'd be the f of x. So the domain of the composite function and the domain of the inside function, the two you overlap for the last kind. Okay, that's the general overview. Any of these you'd like specifically to have help with? And don't feel bad about asking questions. That's how you're going to get your best help today. Yes, ma'am. 3B, yes. And specifically, there's so many parts to it. Are there any that you totally are fine with, or do you want me to focus on a certain one, or the whole thing? Yep. All right, so for that part of this problem, if I'm doing f over g, first of all, I find f square root of x plus 4 over g, x minus 2. There's my new function, the f over g function. Okay, now I want to know its domain. On this kind, remember there's 3 number lines. And this one's the domain of f, this one's the domain of g, and this one's the domain of g cannot be 0. Does that ring a bell? Okay. Domain of f, that's this guy. You take what's underneath square roots and you say x plus 4 is greater than or equal to 0, and you solve it. X has to be greater than or equal to negative 4. So here's a negative 4. And it has to be greater than or equal to that. There we go. The domain of g. This guy's domain, a lot of times the easiest ones are the most confusing. The domain means everything works except what? And sometimes everything works. In this, there's nothing that would crash that function. So all reals. And then the third number line, because this is a divide kind here, what's on the bottom can't be 0. Want to help me with that part? So what's on the bottom, g or f? And if g's on the bottom, if this is on the bottom, right there, what cannot happen so that function would be 0? X can't be 2, exactly. So here's 2, and it can't be that. But it could be everything else. Remember, we're only trying to eliminate what would make that bottom function 0. So now the final answer is, where does it all overlap? And it all overlaps from here up until the 2, and then after the 2 it all overlaps. So there's your domain for that part. Sure. I'm going to do it on that same problem. How about if I do it on a different problem? Do you want me to do A? Is A okay? All right. So that's the f of g, like this one. I'll do this kind over here. Okay. So then f of g of x, and then I'm going to put the g into the f. This one goes inside the other one. It's like it gets swallowed by the f function. That's going to go into there. So 2, empty spot, big enough to put in the x squared, minus 1. And then I drop into its stomach the x squared. Okay, so the g got put in the f. Do you get that part so far? Okay, so that's my composite function. Now, if I can simplify it, I should, and I can. So I'm going to say 2x squared minus 1. Okay. Now, on this kind, there's 2 number lines to overlap to see its domain. It's the domain of the new function, the composite function. What's this guy's domain? Yep, everything works. All reals. Okay. And the domain of the inside function. The inside function in this case is the g of x. And the g of x is this one, and the domain of g of x is all reals again. You can't crash x squared, right? So since all reals overlaps with all reals, the answer is all reals. Okay? Maybe that's enough on that page. Again, I'm willing to stop if you want, but I had to work really hard to get people to ask questions on that page. Are there any others in here? Maybe? Problem 4, 5, 6, 7, 8, blah, blah, blah. Anything in here you'd be scared by on the final? Again, I'm asking you to stay with me as we flow through this, and if I start working on a problem you've already done, then you can go work on what you want. It's R. Sorry, which problem number? 7, E as an elephant? All right. That would be this one, correct? All right, let me look at the directions here. Find the inverse. Inverses. Do you remember the 3-step process for making an inverse? The first step was take f of x and make it equal to y. That's kind of a dumb step because you probably could have just like done that in your head, and then change around the x and the y is the next step. X equals y plus 3 over y minus 2. Now a bunch of things start coming into play that we've been talking about forever. If you're solving an equation, one of the most important things is to know how to clear fractions. So right now we should clear the fraction. So everybody go ahead and multiply that on both sides to clear that fraction. They're on E as an elephant. Be with me. Okay. So Mr. P, what do I multiply by on both sides? Close. I've changed it to have a y on it. There you go. Multiply by y minus 2 on both sides. And that way this and this cancel. Cool. Now I should actually multiply it out. X times y is xy. Minus 2 times x is 2x. Equals y plus 3. Okay, now, if I'm going to try to get this y alone, remember, trying to solve now for y, because we reversed x and y, and now trying to solve for y. All right, so now I'm going to get the y's all together on one side. That needs to come over here, and the x needs to go over there. I'm running out of room, and the way this writing on the PDF works, I'm going to have to go up to the top here and rewrite this. So I'm going to rewrite all this stuff up here. And after I have added 2x to both sides and subtracted y. So xy is still there like it was before. Now I'm going to put the minus y over next to it because I took y away from both sides. That's this one. Subtracting y from both sides. And then I'm going to say equals, and then I'm going to put the positive 2x on the other side because this moves over to the other side, plus 3. Okay, now this requires a little leap. Who remembers the leap? Yes, ma'am? Yes, the y needs to be factored out. And then to get y alone, I have only one more little step. Because see, once I factored the y out, I only have one y left. That's critical. If you get it down to just one y, then you can solve for that y. That just meant there was a y here and a y there, and I factored it out to the front. So now I'm going to divide both sides by x minus 1. And now y is alone, and it equals that. 2x plus 3 over x minus 1. Now, that's an inverse. Just a quick reminder, the domain and range for the inverse, I should not look at my end product here and say, what's its domain and range? Do you remember that you have to go back to the original problem, find its domain and range, and then flip them? Okay, so I'm going to go to my original. My original problem here was right here. I'm going to find its domain and range, and then I'm going to reverse it. So whatever was the domain will become the range, etc. The domain on this guy is all things work except what? what would crash your function? 2. So all reals except x cannot equal 2. Could I have written that out as from negative infinity to 2, union with 2 to infinity? Yeah, I could do it that way too. The range of it, this one, the range, remember, means up and down. Remember that if I were to go from up to down, the only thing that would stop me on a rational function like this is any horizontal asymptotes. So if there was any dotted lines like this, they would stop me from going up and down. Okay, otherwise these functions go everywhere except wherever there's a horizontal asymptote. So Bob tells you the horizontals, and they're also the horizontals. Remember that? So they're y equals things. And Bob, is this a Bob actually? No, it's the same on both. And you remember the rule for those? That's a 2-second reminder. Bigger on bottom is y equals 0. Bigger on top is none, because there's no bots. No horizontal asymptotes if it's bigger on top. By the way, there might be a slant asymptote, but you'll learn about those in calc. All right, on to same on both is y equals a ratio of the lead coefficient. Okay, so then this is the same on both because the degree on the top is 1, degree on the bottom is 1, so it's the same on both, and the lead coefficient is a 1 and a 1. So it's y equals 1 over 1, which means y equals 1. Okay, so that means what? That means that it can be everything except if y equals 1 is an asymptote, y cannot be allowed to be 1. So I just figured out what's allowed for the range. Everything except the horizontal asymptote. That was the horizontal asymptote, so it's not allowed to be that. So then, to get the domain and range of this new function we created, down here, the domain becomes the range. So the range turns into the domain, and that's all reals except y cannot equal 1. And the range is all reals except, and this is coming from the domain, x cannot equal 2. And wait a minute, domains and ranges would have to be reversed. Domains aren't about y's. So I change this to x. And ranges aren't about x's. Y cannot equal 2. It's a not equal sign. That's so messy. I'll try again. Y not equal to 2. Okay, so find the domain and range of the original and reverse them. All right. What else you want from this page, from the page that starts with problem 7? Yes, ma'am.
Can we go back to 6A?
Yes, we can go back a notch. Everybody, please look at 6A. Find functions f and g such that f of g of x, I hope you get that this means f of g of x equals h of x. Okay, so then they're saying, here's the answer, and what were f and g? If this is the answer, that is the combination of the two of them, where the one was in the other, what are f and g? That's what they're really asking. So now, that's called decomposition. Instead of composing a function, taking this function, putting it in the other one, we're taking the answer and breaking it up. Decomp. Okay? So if this is the final answer, what could f of x have been, and what could g of x have been? Well, you start with the one on the inside, and g's the one on the inside, and you say to yourself, this could have been the thing that got put in the other one, like that. So we say g of x could have been x plus 3. And then what would f of x had to have been? Well, this must have had an x there then. And it would have been x to the third minus 4. That way this can go into that and make that. Oh, wait, I need absolute values somewhere. That needs absolute values there and there. Yes?
Then where f of x is absolute value of x, and then g of x is plus 3 to the third.
So you're asking if this could have been absolute value of x, and then g of x could have been all the other stuff.
Yeah.
X plus 3 cubed minus 4. So then really all you have to ask yourself is check yourself, kind of like factoring. You can always multiply it out and check if it worked. You take this, you stick it in there, and would that equal this? And the answer is yes. All right, that's decomp. We're not going to get through this whole thing today, but I'm thinking we got another page or two. I got another page or two in me. So, anything else off this page that would scare you if you came to it on the final? Let's move on to this page, 8. Remember how to do these kind. Just to clarify, your final is not multiple choice. It is graded Marzano style. So here's there's good news and bad news. Bad news is that, you know, a normal test would have typically 4 R3s on it. And you guys just took a cumulative test the other day that had 4 tests, each of which had 3 questions. It was 12. That was 12 R3s. That was a longish test, kind of hardish test. Okay, so you theoretically have established that in a class hour you can handle 4 times 4 is 16. You had 16 R3s on the cumulative test the other day. And I know it was a longish test. You're going to have about 32 questions on this test. So you have a much longer hour because the final hour is much longer, but it'll be like 2 of those cumulative tests you took the other day. Okay? So it's also graded Marzano style, meaning that if you get 75% of the R2s and 75% of the R3s, then you're going to get an A. So you can get an A with 75%. There won't be too many of your finals that you'll be taking this semester where 75% is an A. Yes? Good question. Will there be R2s? I do not know that answer right now. I will check on that for you and get back to you tomorrow. It'll either be half of it'll be R2s and half will be R3s, or it'll be all R3s. I do not know that answer. Haven't seen the final product yet. Yes?
If it's all R3s, how would that work with like the 75% or whatever?
It would just be 75% of the total if it's all R3s. All right. Any other, and I may even be able to get that for you later this hour. I'm going to check on that one because it's a very good question. All right. So this one's the acid questions. You remember how to do those? We just did them recently. You know, amount 1, percent 1, plus amount 2, percent 2. Good on those? Okay. How about this f of g of x equaling x and g of f of x equaling x? Do you remember that? You have 2 columns, and you do f of g of x, and then you do g of f of x, and then they better both come out to x at the bottom. Know what I'm talking about? And we've never done one like this where it didn't come out to be inverses, so we know the answer is going to be x. It's just about showing your work of how this reduces down and this reduces down, and make sure you're doing it in the right order. Do you want me to do one of those, or? Okay, which one? A? All right. So I'll just leave my starter right there. And f of g of x. The g needs to go inside the f. So that has to go inside that. So I go 3 empty spot where the x is, minus 2. That's the original function without the x. Now I'm going to drop in x plus 2 over 3. And now I've got to cancel things in the right order is the main point. So where do you start on a problem like this? With the multiply or with the subtract? The multiply. So this cancels this first, and then I have x plus 2 minus 2. Then you can get rid of the subtract. If you had done it in the wrong order, I'd have to mark it wrong. There we go. This one, f of x is on the inside, so that one goes into that one. So I go empty spot plus 2 over 3, and in the empty spot I put 3x minus 2. Now in this it's hard to know what to do first, but you have to think back to the order of operations. Parentheses are first. There are some parentheses here you may not be seeing. There's parentheses around the top and bottom of any fraction. Technically, you don't need parentheses around a single number like this, right? So we don't need them there, but there are parentheses up there. That means we have to do that part first. So the stuff in the parentheses would cause me to get rid of that and that. And so now I have 3x over 3, and then I can cancel the 3's, answer being x. There we go. That's doing it in the right order. Remember, you're going to be turning this puppy in. So I'm giving you free answers here. So I'm going to recommend that you get that copy down quick if you haven't already. Some of you have gotten a little lax here. Is there an answer key to check your answers? I do not know that. Has anybody looked? And there is one? Excellent. Okay. I would hope that there would be one. I just didn't know if it was there yet, but it sounds like it is. Now, do you have to do this entire packet? Nope. But what I'm expecting is that you'll skip maybe 1 out of every 4 problems or so. So in other words, 3/4 of it ought to be done. Now, I'll have to grade this by looking at your iPads. But this is important to me. Have this done for the final. Otherwise, you're saying, I'm not going to study for this final. Which means, in turn, we, in the past, have not guaranteed you that 50% floor. In other words, for the lower kids in here that are scared about passing this final, we're guaranteed to at least get a 50% as long as you've done your packet. Okay, if you decide, I'm not even going to do that, well, fine. Then you're running the risk of no safety net for you. Besides, also, at the end of the semester, I make the call on whether or not there'll probably be about 5 of you that'll be that close to the grade above. Like, oh, I missed it by 0.4%. When you show effort in this class, that gets rewarded. When you decide, not that important to me, I'm not doing the homework, then you don't get the little, oops, you just missed it. You don't get that kind of a bump. Okay? And that does, I know if people were watching me make those final calls, some of them would be like begging, oh, please, I'm so close. You know, you can handle that right now by showing effort. That's how I make those final calls. All right, so moving on. I think the acid problems are probably good. We've done them so recently. Just a second, I'm having trouble clearing that. Yes, I can do number 11. All right. Several of the World Cup soccer matches are played in Stanford University Stadium in Menlo Park, California. The field is 30 yards longer than it is wide. Oh, actual math. They're saying I don't know the width. They're saying that it's 30 yards longer than that. W plus 30. Notice me labeling and drawing and labeling the right shape. Then I got to figure out a formula I can put over here that I can stick the stuff from the picture into the formula. The area is 8,800. I'm going to put that on the inside. That's where I usually put areas because it's kind of how that's where the area is. It's on the inside. What are the dimensions of this soccer field? Can use a calculator. All right, so there are parts on this final where calculators would be allowed if this was on that part. Obviously, you're going to set up an equation, and then probably, if you can use a calculator, you probably want to graph both sides of the equation and see where they cross. So now let's get this mythical formula. It's an area of a rectangle, so area equals length times width. That's the pure form of the formula. A lot of people think they're saving themselves so much time by not writing the pure form of the formula, and then they get lost. Please start with the pure form of the formula. Underneath it, stick in what you know. I know the area, 8,800. I know the length, it's W plus 30. I know the width, and it's W. And then it's just, can you graph both sides and see where they cross? This one's going to be a parabola because it's got a W squared in it. And this one's going to be 8,800. So on the graphing calculator, make sure you go up high enough. Your Y has to be able to get to 8,800. So you better reset your window so it goes really high. And then this thing goes across here. And then this parabola is, I don't know exactly where, but let's say it's like this. Then one of those two can be your answer. And if there was a negative side, of course, can't have a negative because the negative length of a rectangle makes no sense. And then once I know what W is, let's say it turns out to be like 70, then The dimensions of the soccer field would be 70 plus 30 and 70. So 70 and 100. It's not the right answer. I don't know what it is. You'll have to graph it yourself to figure out what this final number is for W. But make sure you give both answers because it asks for dimensions. If I could give you just a few thoughts on word problems, there are word problems on this test. Number one thing is just draw the picture, label the picture. That can be the hard part. Take the time to label this right with only one variable. Then it'll be easy to stick the stuff from the picture into your formula. And this went here. And then all you have to do is solve your little equation. But the final thing is, make sure you actually answered the question. So like if you think the answer is W equals 70, I'd feel really sad, but I would have to mark it wrong because they didn't ask for just one dimension. Ask for the dimensions with an S. You'd have to say 70 and 70 plus 30, 70 by 100 or whatever it is. Okay? So make sure that you actually answered the question that they asked you. All right. Come on, trying to clear the ink. All right. Do you remember regressions? That should be your happy place. Put in the data on under the stat button, and then you go calculate menu under stat, calculate the linreg, linear regression. What if it's a quadratic? Then use quadreg. What if it's a cubic? Then use cubereg. What if it's a power function? Then you use power regression. So there's 4 different types of questions that could be on there about this linear, quadratic, cubic, or power regressions. They're all the same basic process. I feel like we've done these so many times I probably don't need to practice that one. All right, moving on. Anything else from this page? The Y-intercept? Just answer this question. The Y-intercept is where x equals 0. So I just have to stick a 0 in here and multiply it all out, and I'll have my answer. Okay? That's a really powerful little statement to know. The Y-intercept is where x equals 0, and the x-intercept is where y equals 0. All right. Moving on. Graphing. There is graphing on this test. This kind is the Frankenstein kind of function where you divide it in 3 parts. Remember this? Up until 0, which is basically on this side of the graph, it's -3 minus x. That's the function. And then from 0 to 1, only in this little range right in here, the graph we're going to be doing is just f of x equals 1 or y equals 1 in that little section only. Okay, so if I were you, I'd put in little dotted border lines here, and basically it's 3 graphing problems. And you graph this in the first part, this in the second part, and that in the third part, and where the most mistakes are made is on where they overlap. So like, for instance, this one, I'm supposed to be graphing this right here, in this little area right here, and does it touch on the line or not? If I look up here, it says or equal to 0. It owns 0. So when I'm graphing this, it's a straight line. I'm going to rewrite it as -x minus 3. That helps me see the slope is -1 and the y-intercept's -3. So I'm going to touch right there, and the slope is -1, which means it basically goes like this. Excuse me. So there's my line, and it owns that spot. Now this next little portion right here is between 0 and 1. It's just y equals 1. Y equals 1 is a line that runs just like that. Now, if I had graphed it that way, I would get it wrong because I have it touching here and here. That would be wrong. I need an empty spot on this end of the line and an empty spot on that end of the line, showing that this way the function will pass the vertical line test. As in, if I draw a line right down there, it'll only hit once. Okay, that's the beginning of that kind. That's probably the hardest graphing question. Remember that XY charts can solve this. If you were drawing a blank right here, I'm like, I don't remember how to graph that. Make an XY chart. Say, okay, well, what is it at 0? I stick in a 0. I figure out it's 0 minus 3 is -3. 0, comma, -3 is on my graph. See? Make an XY chart anytime you get stuck on any of these. An XY chart can save the day. This kind, it only really works well at those special spots. Just a quick reminder, this one's the butterfly. What's that kind? Volcano. So generally it looks like this to start with, touching at spots there and there. So I'm going to draw it better. It would be like that and that. Okay, and then it gets moved 2 to the left and down 3 and okay.
What was the butterfly again?
The butterfly is the one that looks like that, and it goes through that spot and that spot. I know it may not look much like a butterfly, but here's the wings. That's one wing. Here's the other wing, and that's the 2 wings of the butterfly, and it kind of goes diagonal like this. Okay, stretching it, I know, but gives it a name at least. Volcano is pretty self-explanatory, but all right. So that's graphing. And I think that's a good place to stop for today because there's just so much to know. We can't cover everything here. We have made it up through page 10 out of 23 pages. So that's we're almost halfway done. Have to say some of the harder stuff's at the end though. So I'll have tomorrow and Tuesday to review with you also. And we'll cover those more at that time. And that's all I have for you for today.